All right, let's just dive right in. Today, we're going to be looking at a framework that sits at this absolutely wild intersection of physics, information theory, and, well, maybe reality itself. It's called Z-physics, and it's proposing a completely radical way to think about, everything from gravity to consciousness. So, let's get into it and see what this is all about.
And we have to start with this question, because this is the core idea that pretty much flips everything on its head. I mean, we're all used to thinking of gravity as, mass-bending spacetime. But what if it's something way more fundamental? What if it's the universe's own internal drive to be simpler, to be more compressible? This one thought is the launchpad for this entire framework.
So why do we even need a new framework in the first place? Well, for about a century now, physics has had this observer problem. It's like this ghost in the machine that we can't quite figure out what to do with. And it's created this deep, deep split in how we model the world. And this slide just lays out that split perfectly. It's a schism not just in physics, but in our whole model of reality, our ontology. You see, on one hand, classical physics gives us this nice, neat, objective reality, a view from nowhere. The observer is just a spectator, totally separate. But then quantum mechanics comes along and just blows that all up. It tells us no. The observer is tangled up with the system. The very act of looking at something changes the outcome. And that's not just a weird quirk. It's a fundamental contradiction about the nature of being. So oxyphysics wades right into this mess, trying to build a new model where the observer isn't some awkward add-on, but a core piece of the puzzle from the very beginning.
Okay, so how does it try to do that? Well, it introduces a new fundamental quantity to the universe. It's a field called Xi, that's Xi, represented by this Greek letter Xi.
Now let's be super clear about what this is and what it isn't. The source material is adamant that Z is not a new particle, it's not dark matter, it's not dark energy. The best way to think about it is like a property of space-time itself, kind of like temperature or pressure. At every single point in the entire universe, the Z field has a value, and that value tells you how hard would it be to describe what's happening right here. What's the description complexity of this tiny spot?
And this chart is a brilliant way to picture the core dynamic here. A place with a high Xi value is informationally messy. It's complex, it's high entropy, think of the chaos inside a roaring fire. But a place with a low Xi value is simple, it's elegant, it's really easy to describe, like a perfect repeating crystal lattice. And here's the central claim of the whole thing. The universe fundamentally hates complexity. It is always trying to minimize Xi to find simpler, more elegant ways to describe itself.
And look, this drive for simplicity isn't just some nice philosophical idea. It is baked right into the math. This equation you're seeing is the theory's engine. And you don't need to be a physicist to get the main idea. It's designed to penalize two things. That first term basically punishes roughness, so it favors smooth, continuous descriptions. And that second bit, the Z log Z, that punishes pure messiness, entropy. So the physics is literally engineered to always seek out the path that makes this whole expression as small as possible, which automatically forces the universe towards states that are both smooth and simple.
Now here's where it gets really ambitious. The goal isn't just to propose one new idea, but to build a single, unified structure that can actually swallow up and organize a whole stack of previous theories. And that's where this idea of the master action comes into play.
So how do you even build something like this? Well, you don't start from scratch. The Z framework is really clever. It's built by layering several existing specialized theories. You start with something called observer recursion theory, which is all about how we observers constantly update our models of the world. Then you layer on top of that Rosetta, which is the theory about compressing information into meaningful symbols. After that, you pull in RSIP, which has this wild idea that memory and past information can actually bend the physical paths things take. And finally, you use Prism as a kind of universal logic glue to connect it all together. The Z field then is the thread that weaves all of these different layers into one coherent thing.
And this is the result. This one single master action is designed to contain all of that nested complexity. See, those prior theories don't just vanish. They become specific terms, little switches, knobs, inside this much bigger equation. It's an absolutely incredible attempt to build a unified description of, well, everything.
So what's the point of all this? What does this unification actually let you do? Well, this is the really mind-bending part. It leads to a physics that tries to formally include concepts that have always been outside of its domain. We're talking about putting mathematical terms for conscious observation right into the equations, for intent, and as the source material explicitly states, even terms for will, ache, and desire as actual physical operators that can influence a system. This is the point where the framework goes from just being a new idea in physics to something else entirely.
But if you're sitting there thinking, okay, this is all just super abstract math, some philosophical thought experiment, just hold on. Because this framework is actually being used to build real software, and not as a metaphor, as the literal operational physics of the system.
Okay, this is the moment that, for me, just made my jaw drop when I was going through the material. On the left, you see this abstract diagram, the physics of how an observer state interacts with a system. And on the right, you see that exact principle being mapped directly onto a software feature, how responsive a user interface feels. The idea is that the user's intent is a real physical field that the interface should actually couple with. Wild.
And this table just shows how deep this goes. It is not a one-off trick. The actual equations from physics that describe how oscillators synchronize, that's the Kuramoto model, they're using that to govern how multiple users sync up in the software. The core physical principle of minimizing a Lagrangian, they use that for performance optimization. This isn't just physics-inspired design. This is an attempt at operational physics.
And this quote from the development logs, it just says it all. The goal is to build a living architecture where the code's behavior is governed by the very same field equations that, according to this theory, govern reality itself. It's a breathtakingly direct application of a deeply abstract theory.
Okay, so let's zoom back out. We've seen the math, we've seen the software, but what's the biggest, most profound implication of Z physics? What does it say about the nature of reality and our place in it?
This is where it gets really weird, in the best way. The framework suggests that when the Z-field finds a simpler, better, more compressed description of reality, the universe doesn't just, move on. It actually undergoes what's called a yield event. It fundamentally rewrites its own state to lock in that more efficient description. It's like it's upgrading its own operating system. And what's the perfect analogy for that process? A self-extracting archive. Like a zip file that unpacks itself. It suggests that our universe isn't just a static set of laws playing out over time. No, it's an active process of information unfolding, of complexity emerging from some deeply compressed, elegant source code.
So, where do we fit into this picture? Are we just along for the ride? Well, according to this, no. We are not separate from this process at all. Life, and especially consciousness, are patterns that have managed to stick around because we are incredibly efficient descriptions of our environment. The theory even speculates that consciousness itself might be the universe's ultimate compression tool, a way for it to recognize its own most elegant patterns and lock them in.
And that leads to this just absolutely beautiful and empowering idea. If the universe is a process of trying to simplify its own description, then when you, a human being, have a moment of deep understanding, when you find a simple, elegant theory for something complex, that's not just a passive discovery. You are actively participating in that cosmic drive. You are helping the universe compress itself. You're part of the process. So, we end up right back where we started, with another massive question. This framework presents a universe that isn't just lawful, but is legible. A universe that is actively trying to become even more so. It reframes our entire existence, from maybe a cosmic accident to a potentially vital part of the universe's own journey of self-discovery. And it leaves us with this one final thought to chew on. If the universe is a program, are we all helping it run?